Sand falls from a conveyor belt at a rate of 10 cubic meters per minute onto a conical pile.
The height of the pile is always 3/8 of the base diameter. How fast is the height changing when the pile is 4 meters high? And how fast is the radius changing at that time?
So one of the facts that we know is that the conical pile is 4 meters high. Another fact we know about the conical pile is that the height in relation to the diameter is 3/8. We know that the diameter is 2 radius. Therefore, the height is 3/4 the radius.
What we're trying to find is how fast the height is changing when the pile is 4 meters tall. We are also trying to find how fast the radius is changing at that same time. What we're trying to find is how fast the height is changing.
This is so interesting. I want to solve this problem.
Okay, so I wrote my problem and I drew the picture and I don't know what to do now. What do I do? Cameron!
Okay, Regina, what's up?
I don't know what to do.
Okay, well, it looks like you did a great job of setting up the problem.
Oh,
You
thank
know
you.
what you need to find.
Yeah.
What do you need to find?
The derivative of h with respect to t
Yes?
and the derivative of r with respect to t.
Right. Both changing variables. Okay? So we can't figure out both changing variables at one time. So we're going to need to put one in terms of the other.
Gotcha.
Okay? So we're going to take a look at this piece right here.
Okay.
You were given an equation. The height is 3/8 the diameter.
Yeah.
What else is the diameter?
2 radius.
2 times the radius. Plug that in for D, solve it out, and put it in terms of R. Then you get the radius is 4/3 the height. Okay?
Yes.
What do you do with that now? Put it into your volume equation.
Yeah.
Alright? Solve it all out so that it simplifies to only one changing variable, the height. Do you know where to go from here?
Then you take the derivative.
Right. Okay? So you take the derivative, dv with respect to time equals 16 pi over 9 h squared derivative of h with respect to t. Then you plug in what you know. You know that the volume is changing at 10 meters cubed per
Because it
minute.
said over here.
That is right.
Yeah.
Okay? And then what else did we know?
We know that that's 4. Because the height's 4.
That's right.
Yeah.
Okay, so solve it all out, solve for derivative of height with respect to t, and you get 0.112 meters per minute.
Yeah, we got this.
Good job. Okay, awesome. So we now know how fast the height is increasing when the height equals 4 meters.
So can we celebrate now?
No, it's too early to celebrate. We still have one more piece of the problem to finish. It's how fast the radius is changing at that same time.
Okay.
Do you know how to do it?
Nope.
Come on, I think you can do it.
You're right. I can do it.
Okay.
So you take what you know from the last problem, which is that the height is 3/4 r, and then you take the derivative of it. So it's dh over dt equals 3/4 dr over dt.
Great job.
And then from the last problem, you also know that dh over dt is 45 over 128 pi. So you plug that in, and then you put the 3/4 on the other side by multiplying by the reciprocal, and then you condense this together and solve, and dr over dt is 15 over 32 pi.
Which is also 0.15 meters per minute.
Celebration!
Yep, go ahead.
Woo!